What is up, amigos? What is the lift coefficient of a koala? What is the drag coefficient of a koala? I'm glad you asked. That's what we're finding out today. So we have a koala here. We have some X-planes going downstream showing the wake of the koala. And a few things. First of all, the wake is quite symmetrical up until the third plane. Then it starts to break down and become quite asymmetrical. That's fairly common of bluff bodies. Secondly, it's not until about the third or fourth plane that the flow becomes quite unsteady. So it indicates that the koala has some sort of quite a large wake which is steady before it starts to break down unsteadily. So this Y plane, which goes right through halfway in the koala, shows just how big the wake is. Look at it, it's massive. And this shows that there's a lot of drag. How much drag is there? I can tell you that the drag coefficient is 0.93, which is really bad. Like, that's almost as bluff as you can really get it. And the flow is very unsteady. You can see just how big the wake is. It's like 3 koalas downstream, you still get a huge amount of blue forming. So it's not great. That's why they live in trees, I guess. And you can see just how big the wake is in this plane as well, where we have a plane, a Y plane, which is like standing off of the koala. It's not even close to its ear. It's still quite far away from the body, and we still have a massive blue wake here. That's how big the wake just pops out to the sides. That's why we get a drag of almost 1. So this Z plane is right at the koala's feet, so just below them, and you can still see a massive wake underneath it. It doesn't extend nearly as far, but it is still very chunky. So this is probably the coolest plane. I think this is the plane around the koala's head and mid-body. And it's cool because the wake, you can see it's very long, obviously, but there are 2 parts to it. Effectively, there's a unsteadiness. If you look closely, there's obviously this unsteadiness from left to right of the sides being shed. That's typical of a bluff body. But if you look a little bit closer, you can see sometimes there is this symmetry where like these 2 bits shed at the same time. So there's this asymmetric frequency shedding and symmetric frequency shedding, which you don't see too often. Also, the lift coefficient of this koala is actually 0.07, so a koala does produce a little bit of lift, which means that if you were to like throw it really fast, it would actually start to fly. So this Z plane is now just above the koala's head, and you can see, first of all, there are 2 little lobes of low flow, so there's these wakes. They correspond to the ears, one for each koala ear. And also the wake downstream is sort of exhibiting that same kind of asymmetric plus symmetric frequency shedding. The asymmetric one is obviously far more dominant, but if you look closely, sometimes there's about 2 or 3 times where this symmetric part occurs. So it seems to be some sort of a macroscopic effect perhaps, or maybe it's the flow coming from underneath the koala shedding in a 3-dimensional pattern. So that's the end of this video. Make sure to like and subscribe, and let me know what you think about this asymmetric-symmetric shedding, if it is in fact 2 different frequencies that are shedding symmetrically and asymmetrically, or whether the symmetrical part is actually an asymmetric shedding from the other direction, which we can't really tell from different angles. Anyway, if you want to get better at CFD like this and or theory, check out our links in the description. We have courses there. If you want to get better at theory, we have them there as well for you. And I'll see you next video. Peace out, amigos.